So now we're on question 2, and it says complete table to distinguish among solids, liquids, and gases using the terms definite, affixed, vibrate, move freely, very weak or negligibly weak, no fixed shape. Okay, so they made it easy. Basically, you're gonna use those words and you're gonna put them in the appropriate spaces. So we're talking about shape. When it comes to solid and shape, it is definite and fixed. So we're gonna write definite and fixed right here. Okay, so we have that. And for gas, it's not definite and fixed. It has no fixed shape. Then for volume, for a solid, it has a definite or fixed shape. For liquid, it moves freely. The atoms or particles, they move freely. You know, in a solid, if you had 9 balls, you'd represent them like this. In a liquid, if you had 9 balls, they'll be close, but they won't be that far apart. They'll be close, they won't be that close, but they won't be that far apart. And so they will move freely. And then for gas, these same 9 balls, so if we're talking about water, would be much further apart, having fun. Right? And they'll be going haphazardly, moving all over the place. So if you didn't remember that, you could draw a simple drawing to help you. So this is a solid, a liquid, a gas. It will help you. So these are how the particles are arranged. So the movement of molecules, which is good now because we have this, you know that solids vibrate. Liquids move amongst one another. I would say that gases move freely. So like I said, we're just using the words that they gave us to fill in here. Intermolecular forces would say that the forces between the particles that keep them together must be strong. These are going to be very weak. And we're just going along with what they give us. So this is my pick. Negligibly weak. And you try to fit everything in this space that they give you. And I'll put the same thing down here. Because in gases, it's really we're dealing with Van der Waals forces. Right? Okay, so that's that for the top, and that was 7 marks. So 1, 2, 3, 4, 5, 6, 7. So you get all 7 correct, and you get 7 marks, and that's my answer for that. Now moving along, it says students in a 5th form physics class use the apparatus in figures 3A and 3B in an experiment to find the specific latent heat of vaporization of water, which is LV. And my students would say that EH is equal to MLV. And we said this is my love. We try to remember it by saying my love. And with this one, we would say MLF. So we say MILF. This is when you're dealing with fusion. So if you want to remember them, my love and MILF. Simple. If you have something else, let me know in the comments below. So figure 3A shows the initial readings as the water begins to boil, and figure 3B shows readings taken after 5 minutes and 45 seconds. So we have the drawing here, and we have the starter, it's the stopwatch, And we have, this is the timer and this is the balance. So this is our watch and this is our whatever it takes, our mass. So in the beginning we start off with 0 seconds and we end up with 5 minutes and 45 seconds. And in the beginning we start off with 375 grams of water and we end up with 360 grams of water. And this is our electrical heater, which will be used to boil off the water. So at least we have that. I'll print this off twice. Okay, so we have that. So then on top here now the asks to convert, it says convert the time recorded in 3 beta seconds. So we know we started off with 5 minutes and 45 seconds. So at least we have some seconds already converted. So if we know that 1 minute is made up of 60 seconds, then 5 minutes will be made up of x. And x will be equal to 5 minutes times 60 seconds divided by 1 minute, and that will give us 300 seconds. So we would add this now to 45 to get 345 seconds. Great, so we have the time. Then it says calculate the mass of water evaporated in the experiment. So we know we started off with 375, ended up with 360. So all we have to do is do the difference. So 375 grams minus 360 grams will give us 15 grams. So that's what we have. Then now C is saying the power of the electric heater used in the experiment was 100 watts. So we're going to write power equal to 100 watts, which is equivalent to 100 joules per second. And assuming no heat was lost to the surroundings, calculate the specific latent heat of vaporization of water, LV. So it will say PT equal to MLV. So therefore MLV will be equal to PT over M. And we just stick in the stuff, joules per second times 345 seconds over 15 grams. This goes, and if you calculate correctly, you will get 2300 joules per grams. And that's my answer. Hope you got it too.